hard. You don't know much about the hardware. You don't know it's very hard to monitor each and every node. And in case of the unbalanced, how to make them balanced, it's not easy. But if we adapt such a master and a slave, the master node will be in charge of all the housekeeping job of the distributed system. Then this is the working node to process the data. Then the main idea of Hadoop is kind of locality, which means after we distribute this is a block data are distributed. Okay? Then the distributed processing, like the MapReduce programming, will running on the node where the data is located. It's the locality. It's a matching. Another interesting is replication to address the problem of fault tolerance. In case this one is failed, there is another replica here, so you can use it. Also, one of the interesting characteristic of the Hadoop is sometimes naming node watch. So you are running the parallel processing, MapReduce programming to process a big data. Okay, huge amount of data. It's running here. But this node, you already probably understand such a situation. Without any reason, computer is very slow, right? Even though it's really identical, so install the same program, running the application, but this one is fast, this one is slow, right? So at that time, if the one of the node is slow, naming node run the same program where there exists a replica of the data. Then see which one is it. Whether this one is catch up, this one is faster. Then if this one is faster, kill the job. And it's a speculation, so it's then try to best performance like this one. So that is the master node. I will explain more details about the architecture of the Hadoop. So MapReduce is basically really divide and conquer. So based on the location of the data, okay, run the divider job. Like this is one of the most popular, the MapReduce programming, like Hello World style the programming in the MapReduce. I try to count the number of the word, okay, from the text file at the time. So we divide the job like there are two blocks. Okay, run the same program and another program. It's the same program, but like the one file is here, another file is here. So count the word. Count the word here, count the word here. So same program is running on the node. Okay? Then at the time, just count we will see later, the one, the cat one, like that. Not the two. It will be overhead. Just the one. Later, once we count all of this, then we are going to sort and merge. Then eventually we will merge. So that is a reducing. So we will see details of that, the MapReduce, the architecture. Yes?
Professor, why we put copy of the same data on different nodes?
The why? What do you think? Why we have the several replica of the data in the different nodes?
If the node fails,
then we need to recover that.
But it will take a lot of space of our
Yes, that is true. So, for example, if we have the 3 copy of this data, which is the default file, the number of replica, the degree. So for example, I have the 3 petabyte size total, but I can use only 1 petabyte because we have the 3. However, nowadays the price of the storage is getting cheaper. Okay, so because of that, we have the more and more replica of that, and also we are using also the compression technique, which we are not going to discuss detail. It provides the 1.4 to 1, the compression ratio. Nowadays, the newer version, the current version is Hadoop 3, which is not the production level, it's just released. that I heard that there the compression ratio is much higher nowadays. They are using the new technology which I do not know yet. So it's much higher the rate.
And Professor, if we want to add a new data, then that data will copy on all nodes?
So we will see details how we can manage the in case we add the file, how the make the replication. It's not just randomly replication. They also consider because between the node it will be network, the bottleneck, which is a huge actual problem in any distributed system. Network is always much slower than the burst speed. Okay, so the communication or transfer is usually fast. However, once the data is transferred outside of computer, which means the internet, it will be much slow. Even though you have the 10 gig, the speed, so it is much slower than the burst speed. Okay, so at the time we will consider something the distance between the node to make the replica. Also, another thing we need to consider is if they are in the same, mostly such the distributed system, it's not like the personal computer. Instead, it's a rack style, the blade. So if you, I think that even this room or another room, there is if you open that, there's a rack, and we can put the audio, and similarly we can put just a blade. Okay, and which means if somebody unplug the power of the one rack, if you keep all the data plugged in the rack, you will lose the data, right? So we need to consider the same rack or the different rack, also different site. What if the entire site is something problem? So we need to consider such a location of the computer. So that naming node also automatically consider the two when they replicate. So this is a map reduce. So next week we will see the more details about the map reduce also. Then in addition to such a HDFS file system and the map reduce, there are many other components that we need. For example, most of the company, I think all the company, they are not using only the Hadoop system for their IT solution. Most of the company, they use the existing computing architecture system like the relational database or the data warehousing system and the BI system. And in addition to the existing system, they build a big data solution. Because the big data solution Hadoop is not the general the computing environment solution. It is for specific purpose, like the big data. What is the example of such a big data?
Transaction system.
One is the
Telecommunication sector.
log data. Log data. There are a lot of log data is generated. Not from the system log, even think about your application program. To debug purpose, you print out a lot. Okay? Many of the application program actually print out line by line, and there's a time and some message and print out. These are very important, like for example network. Network there is a network log and a system log or some application log. So these log data, we need to combine then analyze, like to detect whether they are existing the hacking, like the DDoS. Okay. So whether this is from the same IP, source IP is the same or the different, or this is normal, the request, or is the intentionally attacked to shut down the specific port. So at that time we need to collect. So that is a different purpose from the existing, the online system, right? So most of the company, they keep the existing system solution and the Hadoop. So sometimes the Hadoop system collect the data from such a log file or the relational database. the data from the relational database or other sensor data. So at the time we can use the, for example, Flum. Anyone who heard about the Flum? If you have a chance to drive up to the New Hampshire, okay, so you can find the Flum area. The Flum is the long time ago, the tree. So if you go to the New Hampshire or the Maine, like the log, okay, the log from the mountain, how they transfer the tree, the log, to other place using the river or stream. At that time, they make intentionally the way the water is down. So if you go to the Disneyland, there is the log style ride. It's called a Flum ride. So it's a Flum ride. So which means the data can be transferred from source to destination. So idea of the why there is named as a Flum. So we can transfer the data from the source, variety of source, heterogeneous source to the HDF. That's the Flum. So mostly when we practice, we use this one to transfer data from the log data. Okay? Another one is specifically the relational database. It is true the relational database is mostly used data, the storage in many of the IT solution. So like the Oracle Informix DB2 SQL Server. So sometimes many of the time Hadoop would like to get the data from such as a relational database or the export the process data to the relational database for online processing. It is true Hadoop solution is not online the transaction processing. Instead, it's more batch job. So at the time we can use the Scoop based on one. It's a Java program, so which means it's nothing but JDBC program. Even you can implement this one. It's not very complicated. It's just use the SQL plus the JDBC. Then sometimes this MapReduce is painful or very complicated. So it's not the simple the MapReduce program you can easily understand because you already learned you know the Java and many of the programming. But for those who are not familiar with this, it's complicated. So the company would like to develop the new language to simplify such a MapReduce programming. Like one of them is Pig Latin, is developed by the Yahoo. It's an internal purpose actually, because most of the existing developer they are familiar with the other languages, not the Java. So instead of teaching the new language at the time, the middle of the 2000, so they developed a new language which is based on the shell. So it's a very simple, like load the data, group, or something like that. Apache Hive is more like a SQL style. It's very similar, almost it's based on the SQL 2 standard, but automatically the query will be converted into the MapReduce programming. So you can just code like the SQL, where you say select from where. This query will be converted into the MapReduce program. So that is called the Hive, Apache Hive. So I think in this semester you can practice the Hive because you already know how to use the SQL. And the Pig Latin is also very simple. So your project should include the MapReduce and these two later. We are not going to use the Uzi, but the Uzi is the workflow. Workflow means what? In case the condition, we are going to use the MapReduce. Otherwise, Pig Latin program and combine the result and something. It's the overall workflow. So several components. So in this case, when no data, we will get the data using the Flum. Okay, then the process the such a data, if that is from the non-relational database, we will use the pig Latin, and otherwise we will use the scoop. And there is a workflow we can define using the UCI. What if the file is on the HDFS? Then we are able to access, but it's not very flexible to use. Okay, because think about we have the TXT file on the NTFS, A.txt file. So I want to manage my friend information in the A.txt file. How can you use this? You need to make the program open the file A.txt. It's a read and write, and the read this one. Read A, and then finally you can close the file. It's a little bit complicated. So, and you need to add and so on. Instead, why don't we get the idea of the database? Okay, so that is the HBase. HBase is not like the relational database, but it has some basic functionality, operation provided by the DBMS. Okay, so that is the HBase. So somebody believes the HBase is not database, it's more like the store, which is based on the HDFS. They provide something. Actually, HDFS is read-only. You can just add the data, write once, and read many times. What if I'd like to change the data? No way. So at that time, HBase can be used. And there are some data structure supported by the HBase, so we will see a little bit about the HBase in this semester. More details, I'm going to offer the NoSQL database, including the HBase. Then these are some cases, use case. So for the web and the media and the telecommunication, many of them nowadays, actually, believe it or not, they are using the big data solution. It is true that traditional legacy system cannot address the problem of the big data. So this is one of the example of the Facebook, okay, how they use. By next week, homework. So I'm not done yet, so I'm going to continue today's lecture. But before I forget, by next week, just one page, okay? One page, find any use case of the company. So this is one example, how Facebook used the big data. It's a it's not technical paper. You probably need a lot of the Googling, okay? And search the Google and find the company. If you go to the Apache website, there you can see the list of the company who are using the Hadoop solution for the big data, okay? But they have just a link. Sometimes you need to go to their website, or you need to find the white paper. It's more like the Googling game, okay? But please find one use case, how the company used the big data solution, especially Hadoop solution, okay? It's just one page, so do not put more than half as the figure, okay? So please find. This is one of the example how the Facebook use the big data. Like for example, they store the HBase, but not for regarding to the message they use the different one and so on. So please, you can find. Not all company provide such information, but you can find some information regarding to the use case of the Hadoop. That's then submit to the campus. So why don't you create the assignment by the next week? Okay. Then I will share all such a use case with the others. Then you can see how the industry use the Hadoop solution. Okay. So this is just a quick overview of the big data. Any questions so far? this is a kind of the seminar level. Okay, so more technical level, we are going to discuss the more details. If you already read the GFS, the reading assignment, so it will be much easier to understand. Otherwise, please pay attention to this one. Many of the information much of the I already explained, so I'm going to skip the several part. Who is Grace Harper? Anyone who knows? Anyone? She is the first woman, the female developer who developed a compiler first time. So actually, and also, what is this? So in case of something error or mistake from the programming, you need to do. So she's the one who named the debugging. Actually, she found one system is not working. So she opened the back, the behind the panel, and she found really bug, moth. So took out the moth, then it's working. So after that, if you remove the error or the error checking, so it is called the debugging. Actually, the Grace Harper named this one. But here she contributed a lot, even for the idea of the big data solution like the distributed system she commented on. At least if you major in the computer science, you know the name of Grace Harper. She contributed a lot, the compiler and the programming, or even object-oriented programming, so really a lot. So our solution is the Hadoop, so we are going to take a look at the details about the Hadoop. So this is I think one of the clear slide to show how we can we try to have the big data. So to store such a big data, we can use the existing file system plus the data structure, the management system, like the NoSQL database. Then on using this one, we can do a lot of things. Okay, like you can see the machine learning and the streaming processing, and we can use the SQL to analyze the data, or even the search engine, like the main job of the Google, and the batch processing. So to address this problem, so we are going to use the Hadoop solution. Hadoop actually exactly the same component like this one. So before I explain the details of that, keep in mind that this is the diagram. So for the as storage, we have the HDFS. So when we are saying we implement we have the Hadoop solution, that means we have the Hadoop file system, distributed file system. Then this is the storage part. Another part is how to use this data stored at the HDFS. So MapReduce is the traditional way. Okay. Nowadays it's getting reduced because of the complexity or a little bit difficult and limited. It's because it used the pure Java program. It's the limited, and also that MapReduce is current version. I think is more flexible and is the better performance. But still, it's based on the Java, pure Java. So nowadays, other programming framework Spark. So there are two main programming framework. One is the Spark. Another one is the MapReduce. Spark is supporting the Python and the other program languages. In this class, we are going to use the Python. So if you do not know, if you never use the Python, I think I strongly suggest to start to learn the Python. It will take a couple of hours. to understand the basic of that. Okay, so much easier than the C++ and the Java. Okay, so even the high school, the middle school, the kids that can learn such a Python programming. This semester, do we have the Python class?
I think so.
We have.
I think so, no?
The last semester we had.
Last semester?
So please, I think you don't have to take the course, so you can learn by yourself even. So if you already took the C++ or other, so I strongly suggest to learn the Python. So this is a programming, this is a storage. There is another one you need to understand, that is the resource manager. It was not when I started to use the Hadoop first time and teach the first time, it was not only the two main parts, but the resource manager, the main problem of the MapReduce and the Spark, the first version, the early version, what if this node is the high capacity, like the more the CPU and the faster usually, but this one is not, and so we try to use the faster or the high performance the node for the heavier job and so on. That is the managing, monitoring and the manage the resource over the cluster number of the node. But it was not, because it's just the programming, the platform, not resource management. So we need something to globally manage such a resource along the cluster. So that is added. Later it's called the YAN. Yet another resource. What N stands for? Network? Who we see? So yet another resource, whatever. So it's called the YAN. So YAN is sometimes some of them. Those who are familiar with the MapReduce, they said it's a MapReduce 2. No, it's a totally different one, actually. So YAN, using YAN, you can run the MapReduce. Okay? Sometimes you don't have to use the YAN just to submit the job. Which means once it is submit the job, so it will be the locally managed, not globally managed. There, even though there is the master node cannot fully manage all the resources. So that is the YAN. So nowadays the YAN is used for the better performance of your Hadoop job. Okay. So this is the overall thing, how we can use the big data solution. Like we get the data and the process, get the data and stored at the Hadoop file system, the distributed file system. Then using the other component, we can process, manage the data. Okay? Then also we can use such analyze the data for further processing, like the AI or the machine learning. So, and also we can search the data. Eventually, for example, the Google would like to use this one to search the data. Somehow, so we can understand all the application running on the computer. It's a kind of searching. Anything is the search, right?
Professor,
yes.
That all data processing comes in Hadoop.
This one is a Hadoop, but you don't have to. Nowadays, for example, the Spark is not based on the Hadoop. It can be based on the local, but in our class, we will use the Hadoop as the big data solution.
Okay.
But mostly, it's a kind of pretend. Because you cannot create the really big data, like the several petabyte size data on so we pretend. Okay, so that's the reason I try to implement one exercise lab or Google the cloud computing platform, where we can actually as long as we have the coupon, so you can load as much as data possible, then run the big query. So you'd better have such a real experience. But throughout the semester, the term project, we mostly pretend, like even though the million instances, the total size is the less than 1 gigabyte. Okay, so but in our the class, in this class, we are going to use the Hadoop, but we cannot do all the analysis here the mostly I think the half of in our project. So if we focus on the analyzing part, it will be the part of the machine learning or the deep learning or the data mining class. So we can lose the main purpose. So I'm not going to credit or emphasize on a lot analyze in our project. But if you are interesting, definitely you can do that using the existing solution, or if you already took the data mining class or the deep learning class, you can use such the experience as a part of the project. But so it will be like up to what you need to do in your term project. I will explain more about that. Also, you can think about as an application, it can be search or something query on the application of your big data term project. So we will see later the details about that. I already explained that part. So Spark, Spark also is the one of the Apache Foundation solution. It's the Apache Spark, but it's for the more general purpose. Not only the Hadoop distributed file system, they can use the other data source. So, and also nowadays it will be used for the machine learning and BI solution and the many other. It's very simple. It's very easy to learn. So if you know the program language, it's very simple and also so very powerful. And it can be based on the yarn, so it's a better performance. So in this class, we will learn how to use the Spark. So there are two virtual machine you can use. One is for the Hadoop. Another one is I tried to combine together Spark and Hadoop, but it was not easy. So the second part is based on the Hadoop, but I download that already include the Spark, so we can practice with the second virtual machine. Okay. And Latin and this one. Here is the interface. So if you are interested in you can use. We are not going to learn this one. Okay, so then after the break, now the 7:10. After 10-minute break, we will see more technical how the Hadoop is organized and how it works.